Today we're going to work more on interpreting and computing division of a fraction by a fraction. Okay, first thing I want you to do is come up with at least 5 different equivalent fractions to 2/3. Okay, here's some you could have come up with. 4/6 if it is equivalent because it's double the amount. 6/9 is triple. 8/12, 10/15, 12/18 is 6 times that amount. So these are all equivalent. What about 10/12? Find 5 equivalent fractions to 10/12. Here are some of the equivalent fractions you could have come up with. Molly, she has 1 3/8 cup of strawberries. This can also be represented as 11/8. She needs 3/8 cup of strawberries to make one of her batch of muffins. How many batches can Molly make? Okay, let's think about this. She has 1 3/8 cups of strawberries. So I can make 1 whole and 3/8. And so labeled, they look like this. Now remember that Molly needs 3/8 of a cup of strawberries to make 1 batch of muffins. And how many batches can she make? Well, we need to start taking out 3/8 cups. Well, it just so happens that we have one of them sitting right there. So there's 1 3/8. But to find out how many 3/8 are in 1, we'd need to cut it up into 8ths and start taking away 3 at a time. Once we cut 1 into 8ths, we recognize that we have 8 pieces. So 8 pieces out of 8 that make a whole is 1 whole. And now we can take away our 3/8. There's a group of 3/8. There's another group of 3/8. But we have these 2 left over. What do we say about them? Think of it like this. We are looking for 3/8. Every time we take away a group of 3/8, that is 1 group. So there's 1 whole group, another whole group. This does not equal a whole group of 3/8. It's only part. How many? There are 2 parts. And we would need 1 more, wouldn't we, to make a whole group of 3/8? And then so this would be 2 parts out of, how many make a whole? 3. Remember, we are looking for 3/8. We need groups of 3. And so here are 2 parts out of 3 that make up a whole. And so all in all, if Molly is taking scoops of 3/8 of a cup, she will have 3 whole and 2/3. Now, Molly's friend Xavier also has 11/8 cups of strawberries. He needs 3/4 of a cup of strawberries to make a batch of tarts. How many batches can he make? So Xavier has 11/8 cups of strawberries, and he needs 3/4 a cup of strawberries to make a batch. So we need to start taking groups of 3/4 out of 11/8. So first thing, we can draw our 11/8. I'm going to draw 11 pieces, and remembering that 8 of them make a whole. And now we need to start taking scoops of 3/4. But we don't have 4ths. We have 8ths. What are we going to do? Wait a minute. 4ths. We can make 3/4 equivalent to something 8ths, can't we? In fact, 3/4 only needs to be doubled to get to 8ths. So an equivalent fraction would be 6/8. And can we take 6/8 from 11/8? Of course. And so here we go. Let's take away 6/8. Scoop. And can we take another 6/8? No. Look, we're missing one. We only have 5. We can only take 5/8. But what is that fraction if 6/8 is our whole? Remember, here is 1 whole. We need 6/8. That equals 1 whole group. What part of the group do we have on the right? We have 5 pieces out of how many make one of our group? 6. Remember, we were looking for 6 parts, and we only had 5. So altogether, we have 1 5/6. And so here it is written in number form again, 11/8 divided by 3/4. What we did is we found an equivalent fraction to 3/4 by doubling it, and then we had 8 on the denominator on both fractions, which made it nice and easy. And we then took scoops or groups of 6/8 out of 11/8 and came up with 1 5/6. Let's try this. 3/4 divided by 2/3. I hope you guys are drawing these along with me because it's always helpful to see visually what we're doing. It helps make sense instead of just staring at numbers. So what's going on behind these numbers? Okay, here's my 3/4. I drew 4 because we're dealing with fourths, right? 4 make a whole. But we only need 3, so there's my 3/4. And the question is, 3/4 divided by 2/3. How many 2/3 can we take out of this? Well, that's a problem because we don't see thirds, we see fourths. Can we somehow make both the 3/4 and the 2/3 have the same denominator? Yes, 4 and 3 are factors of 12, and so if we change both fractions to equivalent fractions with a denominator of 12, then we'll be okay. We can take scoops of 12 from something that has 12 parts. In order for us to make these equivalent fractions, by the way, we need to make sure that if we're multiplying the denominator by 4, we have 4 times as much there, then we need 4 times as much of the numerator. On that bottom fraction, it would be 8/12. On the top fraction, we're going from 4 to 12, which is 3 times as much, so we need 3 times as much numerator, which would be 9/12. Okay, so can we take scoops of 8/12 now? Yes. Scoop, there goes one. There's one group of 8/12. Can we take another scoop of 8/12? No, we can't. We only have one part of a group of 8. So if the question is being asked, how many groups of 8/12 can we take out? We can take out one and a part of another. How much of a part of another? Well, one part of another group of 8. And another way of saying one part of a group of 8 is 1/8. We have 1 and 1/8 of 8/12 that we can take away from 9/12. Here it is again. We started with 3/4 divided by 2/3, but we couldn't take 2/3 from 3/4, so we needed to find equivalent fractions. We changed them both to equivalent fractions of 9/12 and 8/12 and asked ourselves how many times can we take 8/12 from 9/12, and found that we could do it 1 and 1/8 times. What about 6/2 divided by 3/4? Can we do the same here? So here I'm drawing 6 halves. 6 halves means 2 of them make a whole, but there are 6 of them. And I'll label it like this. And then I need to remember what I'm trying to take groups of, and that is 3/4. Can I take away groups of 3/4 from halves? No. Instead, I'm going to need to change one or the other or both of these fractions in order for them to have the same number of pieces that make a whole. Then I can take scoops of one from the other. So I'm changing the 6/2 in this case to 4ths, because then I can take 3/4 away from something that has 4ths. And for me to go from 6/2 to 4ths, halves to 4ths would be double, so I'm going to double my numerator too. 6 times 2 is 12. So now the question is, how many 3/4 can I take from 12/4? There's 3, there's 3, there's 3, and another 3. So in the end, I have 1, 2, 3, 4 groups of 3/4 that are inside of 12/4. And so again, this is what it looks like on paper. We had 6/2 divided by 3/4, but we couldn't do that because we needed the denominator to be the same so we could take away groups. And so we doubled the first fraction, making it 12/4, and that gave us 4ths, which is great because we need to take away 4ths. And so then we found that the number of 3/4 that are inside of 12/4 is 4. How about this? 2/3 divided by 2/5. I can draw my 2/3 right here. And now I need to divide this into groups of 2/5. But I don't see fifths, I only see thirds. So we're going to change these fractions so that they have the same amount of parts that make a whole. And to do that, I had to multiply the first one by 5 to get 15, and multiply my second fraction by 3 to get 15 as well. That was the closest common denominator between these two fractions. Once I did that, I could take away scoops of 6/15 from 10/15. There's one. But then I realized that I have 4 parts left. I don't have enough to make a group of 6/15. Oh, 4 parts. We can call it 4 parts of 6 that make the group, right? Because we needed 6/15. But notice that 4/6, that can be simplified. If we divide both by 2, we'll have 2/3. And so, we've found that 2/3 divided by 2/5 is 1 and 2/3. Last one, 3/5 divided by 1/4. Okay, again, I hope you guys are drawing this so you can manipulate them, circle them, deal with everything that's behind these numbers. So here's my whole, but I need 3/5. So I'm going to cut it into fifths, and I'm going to circle up my 3/5. This is the area I'm working with. I only have 3/5. If we wanted, we could erase those other 2/5 just so we're not looking at them. My problem now, though, is that I need to take groups of 4ths away from 3/5. But I don't have 4ths. I only have fifths. So what can we do to fifths or fourths or both to make them have the same number of pieces that make a whole? Fourths and fifths share the number 20, right? That's equivalent. If I took fourths and I multiplied it 5 times, I'd get 20 pieces. And if I had fifths and multiplied it 4 times, I'd have 20 pieces as well. And so here I've taken my 3/5 and I've cut them into 20ths. And now I'm looking for groups of 5 20ths. 5 20ths because that's equivalent to 1/4. Remember, we're trying to find groups of 1/4, which is the same as 5 20ths. So there's a group of 5 20ths there, and another group of 5 20ths there. And not enough, but 2 of the 5 pieces that I would need to make the 5 20ths there. And so altogether, 3/5 divided by 1/4 equals 2 and 2/5. And to sum up our lesson today, when trying to divide fractions that have different denominators, different amounts that make a whole, we need to make those amounts the same. We need to find an equivalent fraction, either for one or the other or both. And then we can start taking and dividing groups.